linked list? This is another very popular question in interview, and very confusing as well. So just pay very close attention to this problem, and try to work with it. So if you understand the linked list, the concept of the linked list, I think it will be very easy for you to work with this problem. And as for the question, given the head of a singly linked list, reverse the list and return the reverse list. So you will be given a list node head, which is 1, 2, 3, 4, 5 right here. And this is the list representations, right? So 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5. And you should, your algorithm should be returning the result like this. Now 5 is going to point to 4, 4 is connected to 3, 3 is pointing to 4, 2, and then 1, right? So basically the pointers, you have to change the pointer, right? As you can see here, it's a list node defined as two properties. One is the integers and the second one is the list node next. Okay, and then these are the constructors. So they the value 1 is showing up here, and the arrow shows the reference of the next one, right? So basically the list node which contains value 1 is having a reference to the node of value 2, and so on. All right, now the ask is here to change the next. Okay, so instead of, like, you have to go all the way. So from the 5 is going to point to 4, 4 should point to 3, 3 point to 2, and 2 should point to 1. Okay, so let's start with the base case where I have the input as null. So whenever, if I have my head is equal to null, or it's empty, or head dot next, or maybe it has only one element in that, right? So that means like it has only one value and the next pointers is nothing. So in this case we can just simply return whatever the input is. So that will cover my base case, the example 3. And now, since we are going to flip the reference of the node, we need to keep track of the previous node as well as the next node. So we do need to define two references. So two references. I will say previous node, that will hold my previous node reference, and I will mark it as a null. And this another one I need is the next node, which will be which we will use to keep track of the next node. Okay, and the previous node which we defined at the line number 14 will be our end result, and we're going to follow the iterative mode, so iterative approach actually. So I will make sure that if my head is not equal to null, I'm going to move. Okay, what I'm gonna do is I'm gonna hold the next node, okay, into head dot next. Yeah, the next, and then head dot next I will change to the previous node. Okay, so prev node I will change it, and since and now my previous node will be my head. Okay, and my head is going to be the next one. Okay, yeah, so this well, this is just a pointer game, and if you don't understand, I will explain to you, but that will do it. Okay, then you can just say previous node is equal to, that's it. You can just return the previous node, and you can run and it will do its magic. So let's run this, and you can see this is amazing. So we were passing it. Okay, what we did, right? See, this is the whole, if you look at the example, what we are doing is, before looking at the picture, let's again revise the definition. So this list node has one value and the reference to the next one. Okay, what we are doing is we are changing it back to the previous one. Now we are here. If I'm highlight, let's look at the number 1. What is the previous node for the number 1? What is the previous pointer? Nothing. It is pointing to, its next is pointing to 2. What we have to do, we have to change this x, the next pointer, to point to the previous one, which is null in the first case. Then second is 2, element 2, which current pointer is pointing to 3. What we have to do is we have to change it to 1. Okay, and so on. and that will finally give us the results like this. Now, you see for previous node, to keep track of the previous node, we have defined one reference. Okay, we create one object which is null, and then to keep track of the next node, we create another object which is also null. Okay, then using the iterative approach, we are traversing through the head, right? So we making sure that head is not equal to null, and because we are working with the first element, we are storing the next node reference. We are initializing the next node variable with the head.next. So head.dex is now pointing to 2. So we are not losing the reference of 2. Okay, that's important. Now, to head.next is also pointing to 2. The next node is also pointing to 2. So it is safe that the head.next we can point to the previous node. The previous node is the one which we defined here. So that's what we're doing. So now we change the reference of the first node to the previous node. Okay, that's good. Now 1 is pointing to nothing. And we also have a reference, the next node, which is starting from the 2. Okay, so the 1 node is disconnected from the list. And then what we are doing is now we are repurposing the previous node to pointing it to the back to the head. Okay, now previous node is pointing to 1. And now previous node we store 1, and now head we are repurposing now to setting the value of the next node. So our head all becomes the 2 now. Okay, then again the loop comes here, head is not equal to 2, is not equal to null. Then again we are using this next node variables to save the next head.next reference, which is 3. Okay, 3 reference 3 4 5. We are holding it to the next node. Now head.next we are pointing to previous node, which is 1, and previous node now is pointing to 2, and head is coming back to 3. So we are just flipping the reference from one variable to another variable, and we will keep doing it until we reach out to the last element, and that will be it. This is the ask here. Okay, it's better to work with this question, and that iterative process is the best one. So if you look for the big notation, so the space complexity of this is O1, because we are not creating any data structure. We are not using any data structure to store anything. Okay, so the space complexity is O1, and time complexity is depend on the number of elements into the linked list. So it's ON. Okay, so how many elements, that's set the complexity. Okay, ON complexity. So that's good. Thank you so much.